How's it going, Jared? What's up, Leanne? How are you, Tucker? Hey, Wilbur. What's going on, Luis? Holden? Almost everybody's here. All right, I'm on the road. I'm teaching from my van today, but I have really fast Wi-Fi. Um, so I think everything should work like normal. If for some reason I get disconnected, just hang out and I'll reconnect. Today, of course, is test review. We're not doing anything new. We're just doing test review. What I usually do is I'll kind of hold you for at least half the class. And then for the second half, I usually make it optional. Like if you feel good, then I'll let you go. Study on your own between now and Thursday. And if you want to stick around, then you're welcome to stick around. I'm sticking around and we can just do more problems. Okay. So let's see. The homework was pretty. You can hear me okay, right? Aurelie, can you hear me okay? Yeah, okay. I think the homework was a pretty short one, right? We just did those inverse functions. So I could take questions or I could just give you a couple. Well, let me give you a couple to try and then I'll take questions. Um, well, let's do this. Oh wait, you can't see my screen. Hold on a second. Share screen. Okay, so this is your test outlined. Let me make this a little bit bigger. And yeah, it doesn't have a whole lot of stuff, but I wouldn't say it's easy, right? This trig stuff is, if it's new for you, it can take a little bit getting used to. But the key is for every one of these, I would say for all these problems I'm going to ask you, other than this one, the trig proofs, and where you're given some kind of value and have to find the cosine is -2/5 and you got to find the others. I'd say at least half the test depends on the unit circle stuff. Okay. The cosine of 3π/4, the sine of 11π/6, all that stuff, right? And then the inverse trig functions are closely related. So the first part of the test, I'm just gonna ask you a bunch of those, right? This is no calculator quiz, no notes, of course. And the first part of the test goes like this. I'm just gonna give you a bunch of these. So let's give you a quick test, see if you know these. This would be this first topic. So I'll just write a bunch of trig functions and then fill in the blank. But I'm also going to do the inverse ones. Okay, so I'll write a bunch of inverse trig functions and you fill in the blank. Okay, so let's see. Special angles, degrees or radians, you got to know. So let's do, I'm going to give you 5π/3. I'm going to give you, let's say, 210 degrees. I want the cotangent. That's cotangent of, let's do pi. Remember, some of these can be undefined. We talk about that. The cotangent, the tangent, the secant, and the cosecant could potentially be undefined. Arcsine -√2/2. Arctangent of 1. Arccosine of -1/2. All right, test your knowledge. See what you can do with these. Remember, you're not allowed to use your unit circle if those of you that refer to that. I don't know how many of you are using that, but I'll give you a blank one. I'll make that a legal document. I'll give you a formula sheet, a blank unit circle if you have a method for filling in the unit circle. And then you can refer to it. And then formula sheet, blank unit circle, no calculator, and that'll be it. Okay, formula sheet will be your final exam formula sheet. I'll talk about that after this problem. So go ahead, work on these so you get. Let me know if you have questions. Okay, how we doing with these? Orelli, do you know what the sine of 5 pi over 3 is?
Do you want the like the point, like the √3/2, or is it the degree that you want?
No, good question. Hang on one second. I'm trying to get my, well, my headphones aren't working. So good question. Remember, I'm asking for the sine of an angle, so you should be giving me the result or the output there. So yeah, be careful. Like I do see that mistake sometimes. I do see students give me, and then just the equivalent in degrees. But you want the √3/2 thing, right? You can convert it if you want, but that's just another way to say 5 pi over 3.
Okay, so
So I believe you said √3/2. Is that your answer?
would it be negative?
Very good. Very good. Aurelia, what's your process? How did you do that? What was your thinking there?
Well, I did the reference angle of 60.
You're going to degrees. That's absolutely fine. That's correct. Reference angle is pi over 3 or 60 degrees. Sine of 60 degrees is √3/2. And then how did you know it was negative?
I kind of followed like the pi, the 2 pi, and just I know that 5 pi over 3 is in quadrant 4.
Very good. You know you're in quadrant 4. Very good. Good. Jared, what's the cosine of 210 degrees?
I got square root of 3/2.
So square root of 3/2. What was your process? How did you come up with that?
I used the reference angle of 180. Or 30. I'm sorry, 30 degrees.
30, right. You got 180 and then 30 more. Very good. So the cosine of 30 is √3/2. That's correct. What quadrant are you in?
Oh, I'm in quadrant 3, so it should be -3/2.
Very good. Very good. Bonus question, Jared. What is the secant of 210 degrees?
Two root.
Yep.
I'm sorry, 2√3/3. Negative.
Very good. Very good. So that's the reciprocal, and you just rationalize the denominator. Good. So anytime if you can do that, you can do that, right? If you can do the cosine, you can do the secant, right? Just take the reciprocal. Good. Holden, what's the cosine, or what's the inverse cosine of -1/2?
I got 2 pi over 3.
2 pi over 3 is correct. What was your process? How did you figure that out?
So I took the secant of it and then I found the inverse.
The secant?
Oh no, the I can't think of the word for it right now.
You're right. 2 pi over 3. So basically what maybe you're thinking of, well, the idea here is you're asking yourself the cosine of what gives you 2 pi over 3, right? You're just kind of flipping them around. I'm sorry, flipping them around. The cosine of what gives you -1/2. You just got to remember with these, you got to be in quadrant 2, right? Because these are things you have to remember for your test. Your outputs for your arc cosine function are between 0 and pi. Okay, good. What do you think, Luis? Can you tell me what the cotangent of pi is? I'm not sure if you're talking.
Sorry,
There you go.
can you hear me
There
now?
you go.
I was saying I'm not sure if this is right, but I got 0.
Okay, so what we do is we get the tangent of pi is 0, right? So you're on the right track. Here's how you can think of it. If you ever have a 0 and you try and do the reciprocal, Then the tangent of pi, you could write it as 0 over 1, right? That's still 0. So what do you think, Luis? Does that help you adjust your answer for this one? Reciprocate 0, what do you get? You are muted if you're, or you might just be thinking.
1?
Nah, this would be undefined, right? Anytime you
Oh,
got
you can't
0
have 0 on the
in
denominator.
the denominator.
Okay.
So you had the right idea. I think you're in the same place because you got 0 as an answer, but that's for the tangent. And then if you reciprocate that guy, you get an undefined. Good. Wilbur, what do you think? Do you know what the arc sine of negative root 2 over 2 is?
I'm not sure.
How about this? Can you tell me this? Give me an angle whose sine value is negative root 2 over 2. What angle are we working with? What reference angle are we working with?
Yeah, I don't know.
You don't remember that one? What do you think, Leanne? Arc sine of negative root 2 over 2?
I got 5 pi over 4.
Okay, I'm glad you said that. It's not right, but that's okay. But I'm glad you said it because you would be correct in this question. The sine of 5 pi over 4 is negative root 2 over 2. That's right. Okay, but remember these, they have those restrictions. The outputs for all my sine values, right? All the outputs have to be between, for sine, it's negative pi over 2 and pi over 2. Okay, so you're kind of like half right, and you have an angle whose sine value is negative root 2 over 2, but it doesn't live in this space. Okay, so you got to get to 5 pi over 4, but you got to go a different direction. So, Leanne, you went the traditional route. You went this way. 5 pi over 4. Sorry, I went too far. You went this way. But we really want to be, if we're following this rule, we have to be here in quadrant 4. But not only do we have to be here, we have to go this direction. Okay, so you got the right reference angle. You're just in the wrong quadrant, wrong direction. Does this make sense? If I follow that, does it make sense? It should be negative pi over 4.
Yeah.
Okay, and there's like a shortcut as well for the sine and the arc sine and the arc tangent. If it's negative, negative, it's got to be negative. All right, arc sine. If this is negative, then this is negative. That works with arc sine and arc tangent. Of course, not for arc cosine because that one had to be different. The arc cosine is negative. This guy's got to be positive. Okay, let's see. Tucker, we haven't talked to Tucker yet. Tucker, can you tell me what the arc tangent of 1 is?
Is it pi over 2?
Oh, close. The arc
Um,
tangent of pi over 2 is undefined, right? So that means if we go with your logic, then this would have to be true. The tangent of pi over 2 would have to be equal to 1. But that's not true because tangent of pi over 2 is undefined. So it should be in quadrant 1. You went too far. You went up here. Oh, you know what? I know what you're thinking of maybe. You did the arc cosine of 1. The arc cosine of 1 is pi over 2 because the cosine of pi over 2 is 1. Or, sorry, try that again. You did the arc sine of 1. The arc sine of 1 is pi over 2 because the sine of pi over 2 is 1. But in the tangent, you should only go this far. All right, remember, tangent's a little bit differently. This is the angle. You're looking at that pi over 4 angle. Does that make sense, Tucker? The tangent of pi over 4 is 1. Tangent of pi over 4 is 1.
Oh, yeah.
So the arctangent of 1 is pi over 4. Okay. So think about that. That's my review. And I can just give you, remember, when I write these questions, all I do is I pick a trig function and I fill it in with a special angle. Or I pick an arc trig function and I fill it in with a special, not a special angle, but a special output for the angle, right? So like something like that. Okay, so any, that's, you know what's coming. Any of those, right? So if I want to do this one, the way we did in class was we did reference angle stuff. Tangent of pi over 4, oh, that's 1. So tangent of 3 pi over 4 has to be 1, but because it's in quadrant 2, I make it negative. For the arc ones, if it's a secant, I can change it to arc cosine. And then the arc cosine of 1/2 from my unit circle, I know is the cosine of 60 is a half. So the arc secant of 2 is 60. Okay, so as we go through this review, make note, what do you need to work on between now and Thursday? And again, if you want to stick around after the break, I can come back to these and do more of these. But let's go to my second topic. Given one trig value, okay. So see what you can do with this one. If I tell you that the tangent of theta is negative 1/3, and I could give you something like this. I can tell you where theta lives. Okay, so that's kind of, or I could tell you that it's, here's another way to say the same thing. Right, or I could disguise it. Be ready for those. We've seen all of those. That's all three of those statements are telling you that theta is in quadrant 2. This one is the one you got to think about more. Say, where is sine positive and tangent negative? That only happens in quadrant 2. Okay. So once you know where theta lives, then you can answer questions like this. Okay. Or I could tell you to find all other trig function values. Or I could ask for one trig function values. Either way, basically you got to just draw your reference triangle and figure some stuff out. So go ahead, take a minute, see if you can get an answer. There's theta, reference right triangle, opposite over adjacent, should look like that. And then did you get for your R value from here to here, or the hypotenuse if you want, square root of 10? Should be negative 3 squared plus 1 squared equals R squared. 10 equals R squared. This guy should be root 10. And then when I want to find the cosecant of something, I find the sine of that something. Opposite over hypotenuse. Flip it around, and there's my answer. Okay. Who's got questions on that? Makes sense. Those ones are typically, that'll be one of the easier ones, hopefully, on the test. What if I ask this question? I've seen this question, a similar question put like this. Given that the point -3, 1 lies on the terminal side of theta. All right, Wilbur, if I tell you that -3, 1 lies on the terminal side of theta, so this is like an XY coordinate, what would the cosecant of that angle be? What's the cosecant of theta? This point right here is back -3, up 1.
So would it be -3?
No, you gave me the cotangent. Cotangent. I want the cosecant. So in other words, it's the same picture. It's the same situation.
So √10.
Very good, √10. So my point is that this kind of question is really the same as this question, right? If you think about it, if I say the tangent of theta is -1/3, and I'm in quadrant 2, then that's the same thing as saying -3, 1. Find trig function values.
What do you mean by terminal side?
Oh, good question. So terminal side, Jared, is when I start drawing an angle like this would be, this is the initial side. It just is fixed. And then once you start rotating, you have another side of an angle, right? So initial side, and this guy we call the terminal side. Right? So that is, for this scenario, I start rotating, and on the terminal side of the angle lies the point -3, 1. Right? So here's my picture for this question. But then the work I do is the same. I draw the picture. All right, here's your terminal side. And then it's back 3, up 1. Does that make sense, Jared? So terminal side is just like, there's always two sides of an angle. And the initial side is always fixed on the x-axis. The terminal side is the other side. Good question. Okay. All right, double half angle. Let's work with those guys. Those ones are a little more challenging, I think. So double half angle. So this is a pretty similar question, actually. If I say the sine of theta is 2/5, and the cosine of alpha is -1/5. And then I have to give you some information about theta and alpha. Let's say I give it to you directly. Theta is in Q2. Alpha is in Q3. And then I can ask you all kinds of questions. For example, I could ask you to find the sine of theta plus alpha. I could ask you to find the cosine of 2 theta. Let's do a half angle. I could ask you to find the tangent of alpha over 2. Okay. So for these questions, the goal is to go to your identity sheet, right, and write what these guys are. All right. They should be in terms of just the sine or the cosine of an angle, not 2 times the angle, not the sum of the angle, not half the angle. Right. And then once you do that, you're probably going to have to go back here and find the cosine of theta. Right. And you're probably going to have to come here and find the sine of alpha, just like we did in the previous problem. Okay, so let's talk about your formula sheet real quick. So again, I know I've given you a couple formula sheets, but the formula sheet you get is the final exam formula sheet, but I have to add, I think I left something off of this, right? Yeah. I'm going to give you this formula sheet, but I'm going to add the half angle. I don't have your half angles on here, so I got to add that. Okay, so for now, they could be found in that other formula sheet I gave you, which is hidden in your notes somewhere, I think. This. Oh, but this one has this bad, well, I shouldn't say bad, but it has the not easy version of the half angle for tangent, okay? So your final exam formula sheet will have your half angles, but it'll have the easy half angle tangent. And I'm going to write that down in a second. But the one point I want to make is that what's not on your final exam formula sheet or your formula sheet for this test is the Pythagorean identities, right? Because I want you to know those. So you got to remember the Pythagoreans aren't on here, and like the basic reciprocals aren't on here. You got to know those. Like hopefully you know those by now. The sine's reciprocal of the cosecant, and the cosine's reciprocal of the secant, and so on. Okay. So see what you can do with this. Where to go? These, and I'm going to write down the easy formula for the half angle tangent, and I'll give you that on your test as well. Okay, sorry about that. I get disconnected every once in a while, it looks like, from my public Wi-Fi, but I think we're back now. Okay. So for theta, if the sine of theta is 2/5, there's my picture of theta. So this should be negative root 20. Okay, so that should allow you to find all your other trig function values for theta. I gotta do the same thing for alpha though, right? So there's my info for theta. And if you want, you can start listing the, the cosine of theta up here, because you're gonna probably need it. The cosine of theta is negative root 21 over 5. Okay. Same thing for alpha. Aurelia, did you get a value for the sine of alpha?
No, I'm still working on that one.
Okay, I'll give you a couple more minutes. I'll draw the alpha picture. So I got a negative root 24. Here's my work over here for alpha. Just draw a picture. Negative 1 over 5, that's a cosine, so that's x over 5, or x over r. And then Pythagorean theorem should give me root 24, but I can do better than root 24. Leanne, you know what root 24 simplifies to?
2 times square root of 12. No, sorry.
2 times.
No, sorry. Yeah, it was, one is, sorry. Let me refresh.
You okay? You got it?
It was outside, well, it's 4 in one and 6 in the other one.
Very good. 4 and 6, and then what does that become?
2 times the square root of 6.
Very good. So root 24 is 2 root 6. So the sine of alpha simplified should be negative 2 root 6 over 5. Okay, now it's just a matter of putting stuff together and cleaning up probably some messy functions. So when I'm asked sine of theta plus alpha, I go sine theta. Look it up on your formula sheet, cosine alpha plus cosine theta sine alpha. Then I do this. Right? I know these should be fractions, especially if you're doing a non-calculator test, you're not working with decimals. So now I'm going to fill in these blanks with 4 fractions. Notice we're not even finding the angle. Oh, that reminds me. I got to add one thing to my list here. Solve a right triangle. Okay. All right, so let's see if I have all the information I need to solve this problem. Sine theta, that's 2/5. Cosine theta, that's negative root 21 over 5. Sine alpha, that's negative 2 root 6 over 5. And the cosine of alpha is negative 1/5. Good news is we have the same denominators everywhere. So I should be able to have at least a common denominator without too much trouble. That's negative 2/25. And then this would be plus, because these are both negative, plus, that's a root 21, sorry. So remember, you can multiply under roots. So I can do this 6 times the 21. That's 126 under the root. And then my denominator would be 25. Okay, so my final, almost final answer would be negative 2 plus 2 root 126 all divided by 25. And then I have to decide if there's something that goes into 126 to simplify. Okay, so that's not a very nice number, but yeah, and if you don't have calculators, I don't know if I'd be too picky. I'd expect you to simplify root 24. You should be able to simplify 126 if it simplifies. I think 9 would go into that. Let's find out. 9 would go in. So 9 times what gives you 126? 1 with 3 left over, I think 14. And then I could write that as 3 root 14. Okay, so I'll try not to make you do something like a big number like that without a calculator to simplify. If I did that right, that should be 2 times 3 is 6 root 14 all over 25. Exact answer for the sine of theta plus alpha. Okay. These other ones work the same. Actually, the other ones are easier. That one was a little mess, but I think they're all written in terms of sine and cosine, right? So once we have these 4 things up here, we can do all these problems, right? After we did this, and after we did this, we got everything we need to answer these questions. For example, cosine 2 theta. There's 3 of these. I can use any one I want. I'll just use cosine squared minus sine squared on my formula sheet. Cosine of, remember, this is theta. So the double angle doesn't have anything to do with alpha, right? So this would just be working with theta. The cosine of theta is root 21 over 5. I'm going to square that. And the sine of theta was given, that's 2/5. So sorry, it's getting a little messy here. Remember, when you square a negative, you get a positive. When you square a root, you kill the root. So negative root 21 over 5 squared is 21/25. 21/25. And 2/5 squared, I forgot my squared, is 4/5. 4/25 rather. 4/25. So 21/25 minus 4/25 is 21/25. 21/25, 21 over 25 minus 4 over 25, and I did not do that right. Glad I wrote it down. 17 over 25. Sorry. It's really small. 17 over 25. Okay. Let's see. And as you can see, these all really work the same, right? Any half angle formula I use, any double angle, any sum of two angles, they all work the same. You just have to find all the information about the angle itself, and then you can attack the problem. So now let's see if we can find. This is the formula I will give you, I promise. It's much nicer than the one on your current formula sheet with all the square roots. 1 minus cosine theta over sine theta. So 1 minus, oh, well, all right, I don't mean to confuse you here. I'm asking about alpha over 2. I tried to give you your angle as a kind of generic angle. We use theta a lot. So alpha over 2, then my translation would be 1 minus cosine of alpha over sine alpha. Sine alpha. Right? Again, we're asked to evaluate an angle divided by 2, and we can get there by evaluating the angle itself. So let's see, cosine alpha, -1/5. 1 minus -1/5. Sine alpha, -2√6 over 5. Okay, good. -2√6 over 5. This is my answer. Right, I just got to simplify that thing. Does that make sense? Is anyone have any questions how I'm doing this? Does this make sense so far? Apply your identity, check. Plug in values for cosine alpha, sine alpha, check. And then the rest is just some arithmetic to clean this thing up. Which would look like what? So that's 1 plus 1/5, that's 5/5 plus 1/5, that's 6/5. And let's just go ahead and take care of this division. Positive 6/5 divided by this fraction is the same thing as multiplying by its reciprocal. So I flip it. 5's cancel out, and I end up with 6 over -2√6. 6 over 2 is -3, right? 2 into 2 once, 2 into 6 3 times. And I'll just put the negative out front. And then, of course, we got a lot of practice with rationalizing denominators. So in the end, almost in the end, I get -3√6 over 6. And my final answer, I know I'm going kind of quickly here, so slow me down if you have questions. Or if I made a mistake. My final answer is -6 over √2. Again, ask yourself, can I do this on the test? Or do I need to study this more between now and Thursday? Remember, your tests are your most, one test is, I think it's 15% of your grades. That's a lot, right? Or it's close to that if it's not 15. It might be a little less because of this participation grade. But anyway, it's other than the final exam, tests are your highest weighted assignments. Make sure you're prepared. Who's got
What did
questions?
you get for the one before that again? Sorry.
Oh,
I couldn't,
the
totally-
cosine 2 theta?
Yeah.
Let me zoom in here.
Sorry.
No, it's a little messy. Hold on, let me find it. There it is. So cosine 2 theta, I used my cosine squared minus sine squared. There's 2 others you could use. And then the
Yeah.
cosine of theta was √21 over 5, or negative. And then the sine of theta should be 2/5. So when you square those guys, you get 21 25ths. Right? The square root of 21 squared is 21. The 5 squared is 25. 2 squared is 4. 5 squared is 25. So I got 17. Does that make sense, Jared?
I have no clue. Well, I used one of the other formulas because I want to see if
let's-
I get the same
Yeah,
thing.
let's do
but
it. That would be good practice. Which
I managed to
formula
get
did you
7.
use? You got 7?
Yeah, I use the 1 minus 2 sine squared.
Oh, let's do it. Okay. 1 minus 2 sine squared. Let's do that one. So if you
Problem.
say the cosine of 2 theta is 1 minus 2 sine squared theta, you should get the same thing, but let's take a look. 1 minus 2, and then the sine of theta squared. The sine of theta was
2 over 5.
2 over 5. Thank you. All right, Jared, what's 2/5 squared?
4 over 25.
Correct. What's 2 times 4 over 25?
What did I get? I got. What did I do?
Well, look at what I got. So you got 2 times 4/25, right? You can write 2 over 1. What happens when you multiply those two fractions? What's 2 times 4/25?
Just. For some reason, I all of a sudden forgot normal multiplication.
Yeah.
Over 25.
For
Okay.
multiplying fractions, you multiply the two numerators, the two denominators. So you should get 8/25. I think that's where you went wrong.
Yeah.
And then once you get that, 25 over 25 minus 8 over 25 will give you, and this is good. I'm glad you asked that because it doesn't matter which one you use. You should get the same result either way. 17 over 25 is what we got either way. Good questions. Good questions. Okay. Zoom back out here. Let's see. We did this one. Check. Let's do a solve a right triangle. Check real quick. So this is the only question you really need a calculator for. So I have ways I can ask this without a calculator. Remember solving right triangle. That means I give you like A equals 40 degrees. B equals 13 and C equals, let's, come on, C equals, B equals 3. Oh, C equals, I don't know. Okay, so your directions are solve the right triangle. Okay, so remember, standard labeling applies. We're always assuming that if I have a right triangle and this is angle A, then this is side A. And this, if this is angle B, then this is side B. Okay, so B is 3, A wasn't given, but this angle was 40 degrees. Okay, so without a calculator, B is pretty easy. Luis, what do you think? Can you tell me what angle B is?
$50.
Very good, 50 degrees. There's 180 degrees in a triangle. And then, what do you think, Tucker? Can you set up an equation for me that would allow, oh wait, I know. I don't want to give you that. Sorry. Take that away. I gave you too much information here. And that's probably not even right, the C equals 10. When we solve a right triangle, you only need 2 bits of information and you can find everything else, right? Because the right angle is given. That's automatic. And then you should be able to find everything else. Luis found angle B for us. Now I want an equation to find. So here's how I can ask this question. I'll say, just write equations for me that what you would start with in order to solve, for example, for side A. Okay, so Holden, what do you think? Can you give me an equation that has A as its variable that I could set up to solve for A if I had a calculator?
Would it be like tangent of 40 is A over 3?
Very good. And that's it, right? If you have a calculator, you're one step away from the answer. Yeah. Leanne, can you give me an equation that involves this side C that would allow me to solve for C if I have my calculator?
You mean like to find C? Like,
Yeah, something that looks like this, but not exactly like that.
would it
How would you?
be C equals like A squared plus B squared? Or, no, I don't know.
Well, so,
I'm confused on this question.
no, let's roll with that one. So look, you're right. You can use Pythagorean theorem, but what I need when you give me your equation is I need to know the other two sides, right? If I want to
Yeah.
solve for it. You do have B, so you'd be good in that case. But you don't have A, right? You could do this since A is since you did this part, you could solve this for A. This would be a creative answer that would be okay. 3 times the tangent of 40 degrees squared. That would be right if you had A. We don't usually do it that way.
Yeah.
But Leanne, how about a trig function that involves side C, involves side B since you know it, and then one of these two angles? We'd have to ignore A. So like sine of 40 or the cosine of 40 or the tangent of 40.
Oh. So would it be the tangent of 50?
Tangent of 50, fill in the blanks. Tangent of 50 equals what?
Sine divided by cosine, but
Okay, sine
I'm
divided by
confused right
cosine.
now on the question.
Yeah, no, you're right. So here's what I'm looking for. So if you start with, and you can do some trial and error. So Leanne, if you did that, but instead of going to your trig formulas, I know that's a little confusing because we've been working with those a lot. You go back to your old definitions of SOHCAHTOA, right? The tangent of 50 is opposite over adjacent. Okay, so that would work for an equation for A. But if I want C, then maybe I would pick another function like the cosine of 40, for example, would be adjacent, which I know, 3 over C. Does that make sense? So that would give me, that's how I could solve for C if I was going to. And then I would need a calculator to type in cosine of 40. Or I could give you like, I could just tell you what the cosine of 40 is, maybe, on your test. I could say the cosine of 40 degrees is, and then whatever that is as a decimal, and then you'd be able to actually find A and C.
Okay.
Good. Good. Okay. We're getting there to the hard one. You know what well, actually, you guys did really well on your identity quiz. So that's good. That's good. Because typically those are the harder questions on this exam. Oh, see. Okay, so we just got 2 types left. Let's go ahead and do one of each and then we'll take a break. Okay, so stay with me. This one, what if I asked you for the exact value of, let's say, 7 pi rate? Okay, so you got a couple options here, and I might not tell you which way to do it. You could say, well, That's stupid. Hold on. I want the exact value of the sine. Sorry. Sine of 7 pi. Okay, so your choices would be to, here's how we handle these. This isn't a special, what I call special angles, right? Your choices would be to try and figure out a sum or a difference that when you add two angles, you get 7 pi over 8, right? We've done those before. Or to me, the half angle is what comes to mind for this one, I think, right? For the half angle, I say, well, wait a minute, 7 pi over 8, that's half of 7 pi over 4, right? That's the easiest way. You could probably figure this one out, but it's a little harder to do that. So I'd probably go to my half angle formulas. And then as long as you can always convert to degrees if you want. Some of you like to do that. And then you might figure out that 7 pi over 8 is whatever that is as a degree is 2 times or half of a special angle 7 pi over 4. 7 pi over 4 is 315 degrees. Okay, or I can just stay in radians and then I can go to my formula sheet. Right, so I go to my formula sheet, the half angles are on there. I actually am looking this up right now because I forget this one too because they're so similar. I always forget this. It's 1 plus, nope, got it wrong. 1 minus the cosine of this angle. Right, and again, that's the point. To be able to write this in terms of a special angle. Right, now I know what the cosine of 7 pi over 4 is, but I don't know what the anything of 7 pi over 8 is. Okay, so it's 1 minus the cosine of the angle itself over 2. And then we got to do the plus or minus thing. We got to decide which one it is. The half angle is the only time we have to deal with this guy. Right? I have to decide which one of those to take. It's not both of them. It's one or the other. Okay? So I'll do that last. Let's go ahead and knock out the arithmetic, and then we'll talk about the plus or minus thing last. So it's plus or minus the square root of 1 minus the cosine of 7 pi over 4. I go 7 pi over 4, reference angle pi over 4. Cosine of pi over 4, root 2 over 2. Okay, go ahead, Jared. You got a question? No? So the cosine of 7 pi over 4 is also root 2 over 2, but I don't make it negative because it's in quadrant 4. Cosine's positive there. So I got this ugly thing. Right? It's not terrible. It's a complex fraction. We've seen this a lot. So I do that. Right? I multiply by 2 over 2, a form of 1. And it'll make my answer look, well, fairly nice. I still got this big root. So it's 2 minus root 2 over 2 times 2. The 2's would cancel out. And then I get a 4 down. Wait with me so far? It's one of those weird answers we get a root in a root, but that's okay. Remember, if I have a square root of a fraction, it's the same thing as this, the square root of the numerator, square root of denominator. So I can at least get rid of that root 4. So I don't have to rationalize. That's good. Because the square root of 4 is 2. And now my answer looks like this. I'm almost done. That square root of 4. Okay, don't give me the plus or minus. I know that's part of your formula, but you have to decide which one it is. Okay, so that's the last thing to do here. Now, how do I figure that out? Well, it's the sine of this angle, right? Back to the original problem. So as long as you can figure out where 7 pi over 8 lives, which quadrant it's in, then you should know if the sign is plus or minus. Right? So 7 pi over 8, oh, that's 7 pi over 8s, right? Or 3.5 pi over 4s if you want. Or you can convert it to degrees, right? Or However you want to do that. Everyone should be able to figure out where 7 pi over 8 lives, right? If you want to convert it to degrees, that's fine. If you want to just try and logic it out, that's fine. I guess the other option would be to do it this way. Here's another way to do it. Where is, so 7 pi over 4, you can start with the angle that we work with. 7 pi over 4 is in quadrant 4, right? See if you like this method. 7 pi over 4 is in between 3 pi over 2 and 2 pi. So I need a statement for 7 pi over 8. So I divide everything by 2. Right? Because 7 pi over 4 divided by 2 is 7 pi over 8. And that gives me the following inequality. It gives me 7 pi over 8 is in between pi and 3 pi over 4. That's quadrant 2. In between 3 pi over 4 and pi. Right? That's the end of quadrant, the second part of quadrant 2. And the sign we know is positive there. So finally, I'm done. Take the positive. Okay, who's got questions on that one? It's kind of similar to those, the problems we did before. Kind of similar to the problems we did before. Kind of similar to that one in that you know what the cosine of one angle is. In this case, it was given. In this example, it was a special angle, the 7 pi over 4. All right. Try a trig identity, then we'll take a break. Let's see. Got one here for you. Let's start with an easy one. Prove to me. We did one similar, but these all start to look alike at one point. That the tangent times the sine is the same thing as the secant minus the cosine. See if you can get it. Prove to me that's true. Start with one side, end up with the other side. Okay, so let's take a look. What side do we want to start with here? Tucker, what do you think? You want to start with the right side? You want to start with the left side?
The right side.
Okay, so you're going to go secant x minus cosine x. What's it equal to? What's your next step? Tucker, you're muted. Okay, go ahead.
I turned secant into 1 over cosine x.
Very good. And then what?
And then I got lost.
Okay. You're so far so good. Wilbur, what do you think? Can you do the next step?
You subtract them.
How do you do that?
Um,
What do you need to do first?
common denominator.
Which is?
Cosine x.
Very good. So did you do this, Wilbur?
Yep.
Okay. Tucker, does that make sense? If you're trying to add these two guys together, you need a common denominator. In this case, between cosine and 1 would be the cosine. So you got to multiply the second one by cosine over cosine. Cosine times cosine is cosine squared. And then we're here. Let's see. Do you recognize, Jared, do you recognize what 1 minus cosine squared is? Here's the only thing you get on your formula sheet. It says this. Sine squared plus cosine squared equals 1. So what's going on here? How can I use this to do some substitution with this? What do you think, Jared?
So do you substitute the 1 with sine squared x plus cosine squared x?
You can do it that way. Good. I'm glad you said that. So if you just take out the 1 and plug in this whole thing, then look what you get. Sine squared plus cosine squared minus, sorry, running out of room here, cosine squared. Jared, what's my numerator simplified to?
Just sine squared.
Very good. Very good. That'll work. Here's how we typically do that. We recognize that if this is one of our identities, if I subtracted cosine squared from both sides, then we can go there directly. So if you see 1 minus cosine squared, it's the same as sine squared if you subtracted cosine squared from both sides. Or you can do it Jared's way and say, well, I can replace 1 with sine squared plus cosine squared, and then we'll get to the same spot eventually. Good. Now, again, the good thing about trig proofs is that you know what the answer is, right? So right now I got sine squared over cosine x. And a lot of times that might be a dead end. Right? I might not know what to do with that. However, we're trying to prove that it's equal to the tangent times the sine. So what do you think, Aurelie? Is there any way you can like kind of pull out of a tangent out of here somewhere? Sine squared over cosine? How are you going to get a tangent, one tangent out of that?
Wouldn't we just use one of the signs?
Very good. Right, so sine square means sine times sine. So like I said, you're going to use one of them. Right, you're allowed to kind of decompose that guy, and then there you go. Right, once you recognize that sine squared can be written as sine times sine. Oh, reminds me, I saw on one of your quizzes, somebody did this. Can't remember. And then sometimes we try and do what we did here with this thing. Okay, be careful with that. That's not true, right? This 2 secant x would be secant x plus secant x. Secant squared x is secant times secant, or sine squared is sine times sine. And then we're done. That's a tangent function. That's a sine function. We made it. Okay. I know you've been here a while. We need a break. If you feel okay with what we've done, we got through everything. I did 1 or 2 of everything. then you're free to go. The test will be like usual. You'll have the whole time to do it. You'll come to class, you'll open the file, right? And then you'll just kind of give me the view of you working. I give you the blank unit circle if that helps. And I give you the formula sheet with the half angles in there. If you still want to do more work, I'm going to stick around after the break. Let's take a 7-minute break. I got 1:43. Let's come back at 1:50 and I can answer any questions you got. If you feel okay, you're free to go, and I'll see you Thursday. Otherwise, I'll be back in 7 minutes. All right, guys, I'm back. Who's got questions? What do we want to work on?
I am not getting how to prove the identities.
Prove it. Okay. Let's go
I
through
think that's
one.
where I'm struggling the most.
Do you have one you want to look at in particular, or do you want me to find one for you?
So I did the first two problems of the quiz 10.
Yeah.
I got stuck on number 3.
All right, good. Yeah, let's do that. Do you have it in front of you?
Yeah.
Okay. Can you read it to me?
Yes, it is cosine to the 4th power x minus sine to the 4th x equals to cosine 2x.
Sine 2x, right. Okay. Hang on a second. Get eraser. Okay. So, really, what side are you going to start with?
I wanted to start with the one with the 4 on top.
Yeah, definitely left side, more complicated. So, what can you do with that left side to try and simplify it?
So what came to mind was like putting it all in parentheses and just making it to the power of 2.
That's right. What you're doing is factoring it. That's the difference of squares. And the reason we want to do that, and it's good if that's just your intuition that says, oh, let's just have power of 2. But it's good because you want power of 2 because we have identities for power of 2. So if you factor it, it's difference of squares, cosine squared minus sine squared times cosine squared plus sine squared. Does that make sense? Is that what you got?
Yeah.
Okay, good. Now we're into our identities. You're almost there. You're just, if you can find those two identities on your formula sheet, then you're done. What's cosine squared plus sine squared equal to?
1.
Very good. What's cosine squared minus sine squared equal to?
I don't know.
That's the only thing you're missing. You got the answer if you can find that guy on your formula sheet. We saw him actually today. Cosine 2x. We saw him.
Oh, with the double angle.
Double angle. Yeah, we saw him right here. Look, here it is. Cosine 2 theta is cosine squared minus sine squared. So we went from cosine 2 theta to the cosine squared minus sine squared. In the identity, you want to go the other way. You got cosine squared minus sine squared, and you go and replace it with cosine 2x, and then we are done. Those are interesting. It's so you think you're stuck, Aurelie, but you're just one step from the answer, which a lot of times is how those things go. My advice would be if you're stuck with this and you're just looking at that and not sure what to do with it, just really dig into that formula sheet. And if you can't find cosine 2x, even here would be another way to do it. Let's just say you're missing that one for some reason. Right? You could say, well, I don't know, cosine squared I can replace with 1 minus sine squared. And then I got 2 of those guys. Right? Negative 1 sine squared minus 1 sine squared is negative 2 sine squared. And then maybe you'd catch that one on your formula sheet because that guy's on there too. That's cosine 2x.
Okay. You see, and I've watched the videos and everything for the homework, and then seeing you do it in class, it makes sense.
Yeah.
But when I go to do it, I guess it's the not knowing where to go next, or
Not knowing
I
where
don't
to
know
go. Yeah,
where.
they're tough. And what I would recommend is just try some more practice and see if you get that like light bulb moment. And I can help you with some too. You go back to that homework I gave you. There's step-by-step solutions for all of those. If you remember the homework, I posted like a PDF file and I included those solutions. And then the homework in your textbook also, like, you know how you go to the back of your textbook, it has the answers. They're in there as well, and they're step by step. So like anything, just a little more practice. And just sometimes another option would be, oh, this one I say. Another thing you can try sometimes is to go the other direction. This one I don't think is a good candidate for that though. The other direction, I mean, that's tough to start with this one and go the other way. Here's what it looks like. All right, it looks like cosine 2x. You'd have to start right here and just go backwards. All right, so this one's not a very good candidate for that. You could say cosine squared minus sine squared. Actually, that's not where I want to start. Where do we finish? You could start. I think the last example would be a better candidate for going backwards. But cosine 2x, you're here, and you could replace cosine 2x with this thing, cosine squared minus sine squared. This would be hard to figure out, just to throw in a 1 in there in the form of 1's cosine squared minus plus sine squared. But it's an option, not for this one, but for some of them to try the other direction. Anybody else have questions? What do you guys want to work on? More proofs, other stuff? Oh, shoot, I forgot something. How could I forget?
I was gonna say graphs.
Uh-huh. Who left? I gotta make an announcement. Wilbur, Tucker, and I'll post an announcement. Yeah, let's do one. I'll give you one. See how much you remember. Say I want you to graph for me. So it could be sine or cosine. So graph me the sine of negative 2x plus pi. So give it a go. If you're really drawing a blank, just ask me a question and I'll give you a little guidance. Sine y equals the sine of negative 2x plus pi. See if you can figure that out for me. I want the amplitude. I want the period. I want the phase shift or the starting point. And then the graph. Sine equals negative 2x plus pi. See if you're off to the right start here. You should always factor out the coefficient of x. And then because this is an odd function, should be
Did my internet just go or is his gone? Oh, you're moving. So it's his.
okay. How we doing with this one? You should have an amplitude of 1. And it's upside down. You can make a note of that. It's upside down when you factor that. This is the first step. You always got to factor out that coefficient of x. So I got something that looks like this. And then from here, I can find the amplitude, the period, and the phase shift just based on my rewritten answer. So the period should always be 2 pi over this number. So you got period pi. Phase shift is pi over 2 to the right. Okay. And I do this interval length thing, right? So interval length would be always the period divided by 4. Okay, in this case, that's pi over 4. And then I start labeling all my tick marks, right? So I'll give you like a blank graph.
I guess the only thing that I'm struggling on that is how did you factor out, or like the reasoning behind factoring out the negative towards the front of the sign? So
Good
like
question. That has to do with the odd property, Luis. That's sign of a negative is the negative sign of the positive.
I'll write that down. Because I got everything else. The only thing is since I didn't factor that negative, I didn't reflect it over the x-axis.
Okay, yeah, so just remember that's an odd property. Cosine, if you see that with the cosine, then the cosine of a negative, cosine's even. It would go like that. Cosine of negative is cosine of the positive.
Okay, makes sense. Thank you.
Okay, so let's see. I got to graph the sine function, period pi, that starts at pi over 2 and is upside down. So I'm going to start at pi over 2. And then we're going to go down to -1 up to 1. So down, up, up, down. Should go through the origin. That's the first thing I do when I grade these things. I just kind of look at what's happening at the origin. It can tell me if you got the right idea. It should look something like that. So Luis, yours was the same, but just upside down?
Yeah.
Okay, good, not bad. You just remember this odd property, and then you'd be good. Anyone else have questions or want to share what they did wrong if they made a mistake? Do another one of those if you
I'm
want.
only struggling like when it comes to graphing.
You struggling?
Yeah, because I mean, I did have it like that, but my points were in like on top of like of a pi divided by 2, instead of pi divided by 4, because I didn't have it like that extended.
Gotcha. Yeah, so did you do this? This part really helps me with that, Leanne. Did you do the interval length thing?
Oh, no. But thank you for reminding me of that.
Yeah, that'll help me because I don't know how to really mark these tick marks, right? Unless I take whatever the period was, in this case pi, and I always break it up into those 4 equal parts, right? Because it goes through a complete cycle in like steps of 4. So this step really helps me with labeling my x-axis.
Wait, can you remind me how you get the interval thingy?
Yeah, I always, whenever I find my period, right here, period pi, I just divide that by 4. So no matter what that number is, if that's pi over 2, I divide it by 4. If that's pi over 8, I divide it by 4. If it's 6 pi, I divide it by 4.
Are there any good videos on this anyway?
Yeah, definitely. For graphing, you mean, Jared?
Just for this whole the whatever we just did.
The entire review?
No, just this question.
Oh, the graphing. Yeah. Oh, absolutely. I can post a couple of these. I can find a couple good Khan Academy ones, or I like the organic chemistry tutor. He's pretty good. But yeah, I'll post a couple in an announcement for practice. Let's do one more. It sounds like you guys could use some more practice. Let's do a cosine. Try this. You can take a look at how you're doing so far. See if you got your factored version right and the even odd property right. You know, if there's no negative here, you don't have to really worry about that. But in this case, I'll factor out the -4. Should give me x plus pi. And then the -4. Oh, I got a mistake here. I did the odd property. That should still be negative, right? Because if you have remember the cosine of a negative number is the same thing as the cosine of the positive. So in other words, if it's a cosine, I just drop this guy. Drop it. If it's a sine, I bring it out here. In this case, I just drop it, so it's still a negative cosine curve. I have the period as 2 pi divided by this number right here, this 4. So the period's pi over 2. My phase shift is pi units to the left, right? It's the opposite of that sign. Leanne, what's the interval length for this one?
I got pi.
Pi, you take your
Wait. Oh. I got pi over 4.
pi over 4
Is it pi over?
is close. Oops. So I have the period as pi over 2, right? So just like every problem, we take the period and divide it into 4 equal parts. So if you take a period of pi over 2 and slice it up into 4 equal parts, pi over 2 divided by 4 should be pi over 8. Does that make sense, Leanne? Pi over 8.
Oh. Okay. Yeah.
And then that'll help guide me these guys.
How'd you get the phase shift?
So So Jared, the phase shift is always, once you have x isolated, the x plus or minus a number, then the phase shift is always this number right here. Always. However, if it's a plus, if it's x plus something, it's shifted to the left. If it's x minus something, it's shifted to the right. So the phase shift is pi, and then it's a left shift because it's x plus pi. And the last one, let's go back to the last one. The phase shift was pi over 2, and it was right because it was x minus pi over 2. So that was a right phase shift. So it's always with the, look at the isolated x, and then it's this number right here, x plus or minus whatever that number is.
Got it. Thank you.
If we don't have enough room to extend the graph, if we mark the starting point, like indicating where the shift was, would you still accept that?
Yeah, that'd be okay. As long as I can see, as long as I can tell you got the right period, and then, yeah, I should be able to tell you got the right graph from that. Yep.
Cool.
Yeah, because this one's going to go out pretty far. If we're counting by pi over 8s, we got to go all the way back to pi. I got a lot of work to do here. Okay, so once I got my interval length, I just drew my tick marks. I don't really have didn't give myself a lot of room to squeeze in all those numbers, but I'm just counting by pi over 8 until I get to negative pi, basically, which is a lot. I think that's why Luis didn't want to go all the way back there. As long as you have the right graph, you're okay. As long as you have some of these labeled, I can tell what the period is, then you're fine. I went all the way back to negative pi by pi over 8, which means I need 8 tick marks, right? Negative pi over 8, negative 2 pi over 8, negative 3 pi over 8, negative 4 pi over 8, negative 5 pi over 8, negative 6 pi over 8, right? And I'm reducing my fractions as I go, negative 7 pi over 8, negative 8 pi over 8. And then I do the cosine curve with amplitude 2. And it should be upside down, right? So it's a cosine curve. Remember, cosine starts up or down, depending on the sine. Sine starts at 0. So cosine would be down here. Then I just run through the cosine curve. You can see if you got the right y-intercept. It should be down here at negative 2 if I did this right when you hit the y-axis. Hey guys, that's 220. So that is just about it. Last minute questions before I let you go. Jared, I'll post a couple. I'll find good videos. They might not do it exactly like me, like with the interval length thing. I don't know. There's a bunch of different ways to do this, but they'll be similar. Okay, so you can take a look at those. I'll try and find some that are similar to the way I do it. I like this interval length approach because it just helps me mark my tick marks.
You're still having office hours tomorrow, correct?
Office hours tomorrow, Luis. I'm gonna have to move. I got a meeting in the morning. I'm gonna have to move them to the evening. Are you available in the evening?
Yes, that actually works better for me.
Good, good. Yeah, another student that sees me pretty frequently prefers evening as well. So I'll post that. It'll probably be like tomorrow at like probably a little later, like 8 or 9.
Yeah, that works.
Okay, but I'll post an announcement for that as well. All right, guys. That's it. Decent review. This review also is recorded, so you can rewatch it if you want, and kind of retry these problems to give you a good idea what you're going to be tested on. Yeah, if you don't have any more questions, you're free to go. And I'll see you all on Thursday.
Thank you.
See you guys.
Bye. Thank you.
Dang it.